Good morning, students. In this video, we'll discuss about the digital signal processor, which is a DSP processor. So, whatever the 8086 microprocessor we have seen, just like that microprocessor, we have the digital signal processor. But the digital signal processor plays a major role in different types of equipments, and also this particular DSP processor is working with the highest speed compared to our 8086 microprocessor. So where exactly we are using this particular digital signal processor and how exactly it is working, uh, means how it is working on those signals. All those things we will see in this particular third and fourth unit. Okay. So in case of the 8086 microprocessor, the 8086 microprocessor is not dealing with the signals directly. Okay, but this particular digital signal processor, the name itself says that it is dealing with the signal which is there in the digital format. The signal which is there in the digital format. Okay. So how exactly the DSP processor is working means a digital signal processor is working, and in processing those signals, what are the what is that the procedure means how the signal is feed as an input to the digital signal processor and how the digital signal processor is doing the calculations and performing the operations. We'll see that one as a brief introduction to the DSP processor. Okay. So here the DSP processor, when you are taking the DSP processor, I'm not come to the DSP processor initially, but we are supposed to focus more on what is the analog signal and how exactly that particular analog signal is converted into the digital signal is a question, because whatever the DSP processor which we are using, it is working based on the digital signals. Okay. So for example, if you want to get one idea, I'll give one example for you people. After that, I'll continue this one. The example is if you are, I think you would have given the metadata, that is the fingerprint attendance, electric attendance in our college. There you would have given your fingerprint along with your code. Okay. So whatever the fingerprint you are giving, that information is the analog information. Means the thumb, the fingerprint which you are giving, it is in the analog format. That analog information should be converted into the digital format. Okay, that analog information should be converted into the digital format, and the converted digital format information should be scanned by one of the device and compare that one with your Aadhaar card information. With your Aadhaar card information means that during the Aadhaar card you would have given your fingerprints and retinal scanner, right? So this information will be compared with that particular information which you gave to the Aadhaar card. Okay. So if both fingerprint informations are matching at least the 80 to 90%, then they'll recognize you as a what is that particular person, the code which you are using. Okay. So if your fingerprint is not matching with the already given information which is there in the Aadhaar card, then definitely it will show that the information is not recognized. The information is not recognized. Okay. Now the question comes that what kind of device is residing inside the device which is scanning the information and converting your information which is there in the analog form into the digital format, and converting that information into the digital format and comparing that one with the comparing that one with the already existed data is a question. Okay. So whatever the scanners which we are using, okay, you say that there is a scanner, the fingerprint scanner, but inside it we are having the DSP processor. Okay, digital signal processor. It is one of the application of the digital signal processor. Okay, we have lots of applications in the digital signal processor. Means we are using the digital signal processors in different areas. But I took only one example. And let me take one more example also. So that is nothing but your what is that camera. You people are using the camera to take a picture, right? To take a photograph. Okay. So here taking the photograph means you are trying to store means you are trying to take a snap of your photo and store that one in the memory. Okay. So the snap which you are taking is the analog information. Means physically the information is existed and we can see with our naked eye, right? But that information is should be stored inside the memory in the digital format. Okay. Means someone should be there who can capture your photo and convert your photo into the digital format and store that information inside the memory as digital information. Now, whenever you would like to watch that particular picture, by go through the file system and you are opening your picture, again that information should be converted back and displayed as a picture on the screen. Okay, na? So one of the example is a scanner, and another example which you are using daily usage in your daily usage, which is the camera. Not only the camera, your phone itself is using the digital signal processor. Your phone itself using the digital signal processor. Okay, so if you concentrate on the what is that camera, you people are means nowadays we are having the what is that 16 megapixel, 32 megapixel, all those things. Okay, so what exactly that pixel? What exactly that pixel? Okay, so if you want to realize that one, I'll drag that one to this particular device. Okay, now whatever the explanation we are going to see that one. Okay, so if you want to know what exactly the pixel, okay, so means when you are taking your picture, I'm assuming that this is some area. Okay, now, so here you are residing in this particular box. Okay, so in this area, how many samples you are doing to take a picture? So that is what your megapixel. Okay, means you are having the 16 megapixel means let us suppose for my convenient I am taking what is that this area. Okay, I am taking I'm sorry. Okay, so here I am taking one box. Okay, so here the megapixel is nothing but how many samples you are making at a particular point. How many samples you are making. How many samples you are making at a particular point. So that is indicating your picture. That is the pixel size of your camera. Okay, if you are increasing the number of pixels, the clarity is going to be more. What I mean to say that, let us suppose I would like to show one this kind of square waveform using the two dots. Let us suppose I am taking the one dot over here and another dot over here. Is it showing this particular picture? Is it showing means is this is these two dots are indicating that it is a square box? It is not. But if I am trying to increase two more points, wait a minute. If I am trying to increase two more points, so it looks like 4 points mixly forming one what is a square box. Okay, but if I'm giving the what if I'm drawing the lines, then only it is showing it as a square box. But if I want to show without using the lines, without combining these means without what is connecting these points, I would like to show this one as a square box. Then what I'll do is I'll go to increase more number of dots. Okay, more number of dots, right? So if I'm increasing more number of dots, then what will happen, ma? Now these dots are indicating that it is a square. Little bit clear, right? So previously we took only the two. The two dots are not indicating the square box. If I'm taking the four, they are showing that it is a square, but actually we are supposed to what is that connect them with the lines. But if you see this one without connecting the lines, the dots itself, by seeing the dots, we can say that it is in the what is that square box format. It is in the square box format, right? So means if you are increasing more number of samples, you will get the more clarity in that picture. You will get the more clarity in that picture, right? You will get more clarity. Okay, now. So means more clarity means effectively you can indicate that it is a square box. Effectively you can indicate that it is a square box. So means this one thing is nothing but how many samples you are doing, or I can say that how many dots you are placing at a particular point. How many dots you are placing at a particular point. If you are increasing the number of dots in a particular area, then the shape is going to be more effective one. Okay, the shape is going to be more effective one. So just like that, if you are increasing the pixel size, means so many dots are created at a particular area. If number of dots created at a particular area is keep on increasing, then what will happen? the picture clarity will get increased, just like this what we are having. Just like this what we are having. If you are increasing the what is that number of dots, then your pixel size is increasing. So this dots is nothing but if you are increasing the sampling, how many samples you are doing, how many samples you are doing. If you are increasing the number of samples, then the picture clarity is going to be more. So that is what your pixel size. Okay, so pixel is nothing but they are doing so many samples on your photograph and they are showing it as a clear picture. They are showing it as a clear picture. In the olden days, we used to have the 1 megapixel camera, 0.5 megapixel camera. I think in the 2008 2010 time, 0.8 megapixel camera is a more clarity. Means that is a initial days camera. But if you take that photograph and try to zoom, then you will see that dots. You can't see the picture, exact picture, but you can observe that dots. Some dots you can observe on the photograph. Okay. But if you take nowadays photograph, you will observe the dots, but you are supposed to expand more and more, zoom more and more. Okay. So means the photograph is nothing but so many samples are doing on your photograph means you are getting the more picture clarity. If you are having the photograph very clearly, very clarity, very effectively, means so many samples are done on your face, so many samples are done on your what is that entire picture. So that's why you are getting the more clarity. You are getting the more clarity. So those samples are nothing but they are indicated in the form of the pixel. Okay, na? 16 megapixel, 2 megapixel, 32 megapixel. Okay, na? So I think we are having the 64 megapixel also. So 64 megapixel means 64 mega times a particular area would have been sampled. So because of that only you are getting the more clarity. Okay, now the question comes in, what is the relation between that one and our topic? Actually, it is the introduction to the DSP processor and where exactly we are using the DSP processor and how it is working in a particular cell phone. That's my intention in this particular topic. Okay, now. So here we are having means I would like to explain where exactly we are using the DSP processor and how exactly it is doing. So as I told you that how many samples you are doing, based on that only the clarity of the picture will get increased. The clarity of the picture will get increased. In this case you can't see. In this case you can't see that it is a square box. Okay, but in this case you can say that it is a square box because so many dots are indicated. So many dots are placed, and there looks like the shape looks like a square box. Okay, means how many samples you are doing a particular area, means how many dots you are keeping in on a particular area. Based on that, the clarity of the picture will get increased. Okay, so here I'm saying it is a sampling now. So how exactly this signal is sampled is a question. And whenever you are taking the photograph or whenever you are giving the thumb impression, then obviously that information is in the analog form. Obviously that information is there in the analog form. I'm assuming that your analog information is called as an input and your digital information is called, that is a sampled information is called as an output. It is not the digital, not yet converted into the digital. It is only sampled. So analog signal is nothing but which is a continuous signal. Means the amplitude of a signal is continuously varying with respect to the time without break. With respect to the time, the amplitude of the signal is varying and it is converted into the what is the samples format. I can say that a discrete format by using a particular switch. By using a particular switch. How many number of samples you are doing or how effectively you are doing the samples or how effectively you are doing the samples on the input signal, that purely depends on how effectively your switches open and close continuously. Okay, means with a certain period of time how effectively this particular switch is open and closed, that many samples you are making on the input signal and that many samples are appearing at the output. That many samples are appearing at the output. Okay, so here I would like to show the input signal. So this is my input signal which is an analog signal. This is my input signal which is an analog signal. Okay, so this analog signal is converted into the discrete signal or the sampled signals. Discrete signal or the sampled signals. Actually, for your convenience, I am taking it as a sampled signal, but actually in what is that? If you go to the technical format, we call it as a discrete signal. Means we are not interested. See, the input signal is there in the continuous form. So I'm assuming that this is the time period t, and this is the amplitude. Okay, now this is the amplitude, right? I'm indicating the amplitude with the a. Okay, now AMP for my convenience. I'm taking it as a AMP amplitude, and this one is a time period. Means the amplitude of the signal, which is indicated in the red color, is continuously varying with respect to the time. Continuously varying with respect to the time. And this particular continuous signal should be converted into what? Digital signal, because this information should be processed by the DSP. When you would like to convert the continuous signal, which is the analog signal, into the digital format, you can't convert the analog information directly into the digital format. Actually, you can convert the analog information, which is the continuous signal, into the discrete format first. So that is done with the help of the switch. With the help of the switch. So input signal is the analog signal, and output signal is a discrete signal. So how many samples you are doing, how effective you are doing sampling on the input signal, that is decided by with how much speed your signal is opening and closing. Okay, so this type of sampling format is called as a means with how much how effectively we should sample the input signal, that is explained based on one theorem called as a sampling theorem. I'm not interested to dig more and more in that particular area because it is not concerned to our DSP process. Means actually it is a concern to our converting the analog information into the digital format, but no need to dig more and more. Sampling theorem means it says that input signal should be converted, input analog signal should be converted into the discrete format. Okay, so means these dots, the green color dots are indicating that the sampled information. We are putting the dots, means we are converting the continuous signal into the discrete format. If you want to see that one, let us go to the next slide. So if you see this one, so this is the analog signal, and this signal is over here. Same signal I am taking over here. Okay. So at a particular point, means the switch is closed whenever the dot is there, wherever the dot is there. That means at the time of the switch is closed, this is the amplitude of the signal. At the time of the switch is closed, this is the amplitude of the signal. At the time of switch is open, we don't have anything. We don't have anything. Okay, we don't have anything between these two dots. At the time of the switch is closed, this is the amplitude of the input signal. So means this signal looks like this. Means amplitude is nothing but what? It is a what is the distance from the x-axis with respect to the y-axis. Okay, now so means these are indicating the dots. Okay, now these are indicating the amplitudes. If you want to get more clear picture, so this is what we are having. So here we are having the analog signal. Analog signal is sampled with the dots using the switch. So means analog signal is converted. Actually, the analog signal is converted into the discrete format first. Discrete signal is nothing but discontinuous signal. Okay, so this analog signal is continuous with respect to the time. Do we have any breaks with in the amplitude? We don't have any breaks. The amplitude is continuously varying with respect to the time. Then that's why it is called as the analog signals. Analog signal is nothing but the continuous signal. So this signal is called as a discrete signal. Discrete signal is nothing but the dots are not the continuous one. There is a gap between the dots. So that's why it is not means this signal is not a continuous signal. It is the discrete signal. Means the amplitude is not continuously varying with respect to the time. That is indicated like this. So if you want one more thing, so this is what we are having. This signal is called as a discrete signal. So I just took the amplitudes like that, but directly you can take these samples like this. Okay, so means do we have the continuous signal with respect to the time? We don't have the continuous signal. We have the signal in terms of the amplitude with respect to the time, but this signal is not the continuous signal. Whatever the signal you are seeing on the screen, this signal is not the continuous signal. It is a discrete signal. It is a discrete signal. How exactly this particular continuous signal is converted into the discrete signal? That is done with the help of the switch. What we are taking over here. So with the help of this particular switch, we are converting the analog information into the discrete format. Analog signal into the discrete signal. And now this discrete signal is converted into the square wave. That is a digital signal format with the help of the comparator. With the help of the comparator. Okay. So these discrete signals are fed as an input to the comparator. So I'm using the op amp as a comparator. Okay, it is only for explanation point of view. I'm not considering the more effective explanation. Means I'm not giving the what exactly the input amplitude and what exactly the another amplitude. Okay, so it is only for the explanation point of view. This particular discrete signal, which is having the discrete is not, but it is not the continuous one. It is a discontinuous one, and it is having the different amplitudes. But in the digital format, we should have either the 0 or 1. Means we should have either the plus 5 volts or the 0 volts. Plus 5 volts are the 0 volts in order to convert the discrete signal into the digital format. So here I'm assuming that the input, I'm assuming that this comparator is converting your input signal, that is a discrete signal, into the digital format with the help of the comparator. Means this comparator is converting. But this comparator is converting the input signal into the digital format, discrete signal into the digital format based on the reference voltage. Okay. So if at all I am fixing this particular reference voltage to the 2 volts, if at all I am fixing this particular reference voltage to the 2 volts, 2 volts. Okay. So, and this is the reference signal and this is the input signal. To this particular input signal, this discrete signal is connected. So whatever the sampled amplitude is not greater than the 2 volts, it is not greater than the 2 volts. So let us suppose this signal amplitude is a, for my calculator I am assuming that it is a 1 volt. It is a 1 volt. So here comparison is 2 volts and 1 volt. So it is a comparator acting as a comparator na 1 minus 2, obviously it is a minus 1. So means I am showing it as a 0 volts because it is not the positive. Because the input signal voltage is not greater than the reference voltage, means I am using the comparator in such a way that if the input signal voltage is not greater than the reference voltage, output should be 0. If the input signal voltage is greater than the output signal voltage, let us suppose greater than or equals to the output signal voltage, then I'll make that one as output as a 1. I'll make that output as a 1. Let us suppose this signal amplitude is a 3 volts. This signal amplitude is a 3 volts. Then obviously the input signal, non-inverting input is greater than the reference signal, then obviously output is a positive 1. Then I'll make that one as a 1. Like this, the comparator is converting your discrete signal into the digital format. Discrete signal into the digital format. That is nothing but the zeros and ones combination. And this particular converted information, analog information first. First of all, the analog information is converted. This is the analog information converted into the discrete format. So this particular discrete signal, in order to show more effectively, what I'm doing is I'm taking the two more diagrams. Actually, we can stop over here, but I'm taking the two more diagrams to indicate the amplitudes. Okay, amplitude of that particular sample. So more effectively, this is what we are getting. The format is this is what we are supposed to realize. Means the with respect to the time, we have the amplitude, but they are not the continuous signals. They are the discrete signal. Okay, discontinuous signal, and this signal is converted into the digital format, and the converted digital information is given as an input to the DSP processor, digital signal processor. Okay, so means now this particular digital signal processor takes your signal. Now this particular digital signal processor accepts your digital information and performs some operation on that particular information and stores the information in some area. Stores that particular information in some area, right? So this is what the DSP processor is doing. Now the same thing is happening when you are giving the fingerprint at your attendance, electronic attendance, what you are giving you using the metadata, right? Okay, so when you are giving the thumb impression, then the scanner is there inside your machine. So the scanner is nothing but that particular scanner. If you see that one, that particular scanner is sampling your fingerprint. So many dots are there on your finger electrically. So those sample informations are converted. So sample is nothing but I can say that these are the sample information. These dots are the sample information. Let us suppose so if you see this one, we have the sample so like this. But if you want to get the more clear picture, then you are supposed to do more samples. You are supposed to do more samples. Means I am not interested to lose this particular information also between these two samples. Then I'll increase the number of samples. I'll increase the number of samples. If you are increasing the number of samples, you are going to get a more clear information about your analog signal in the discrete format. So that is what is happening when you are giving the fingerprint. More samples are done on your finger and they are converted into the digital format and processed by the DSP, and after processing your signal in one format, your information in one format, and that information is compared with your fingerprint already given to the Aadhaar card. If both are matching, actually whatever the devices which we are using, they are not accurate. They are taking approximately, if the matching is done approximately say 70-80%, then they'll ask that one as an attendance. Both are matched. But if you are going to the what is that army and army equipment, or here are somewhere more crucial areas, then the accuracy should be more. They are expecting the 99.99% of accuracy. Actually, we don't have the 100% because we don't have the 100% accurate devices in the world. Okay, they'll give the 99.99 accuracy. If the both device both data, the sample data and the stored data both are matched with 99.99%, then only it is going to recognize in the military areas. But if we take it in the what is that student format, then it is approximately 70 to 80% is more than enough. Oh, clear. So when you are taking the picture also, the same when you are taking the photograph using your camera, the same thing is happening. The analog signal is converted into digital format by sampling more, by doing more dots. Sampling is nothing but putting more dots. Means closing the open and close the switch with the highest speed. With the highest speed, then the information will be sampled perfectly and display converted into the discrete format, again converted into the digital format and processed by the DSP processor, and stores the information in the digital format inside the memory. So this is what the area, this is what is happening in a particular what is that camera and the scanner. Not only the camera scanner, in the toys also, in the mobile phones also, we are using that particular process. We are using this particular process. Okay, now, so analog information is converted into the discrete format. Discrete information is converted into the digital format with the help of the comparator. With the help of the comparator, and the converted information is processed by the DSP and stores the information inside the memory. Inside the memory. About clear? So this is what we are having with respect to the DSP processor. Means we have not entered into our topic actually. This is what is happening. Let us take one more example for the explanation point of view. If you take your cell phone, if you take your cell phone and your voice is an analog signal now. Your voice is an analog signal. This analog signal is converted into the digital format. Okay, this analog signal is converted into the digital format. How it is converted into the digital format? What we have seen the explanation means we are having the switch which is opening, close with the highest speed, and that information is in the discrete format, and the discrete information is compared with the comparator and converted into the digital format. That is nothing but the zeros and ones format. That's a binary format. Zeros and ones format. So like that means when you are making a call to someone, okay, when you are making a call to someone, your call is what more? Your voice is analog information. This analog information should be converted into the digital format. Digital format. You are taking the analog to digital converter, showing that it is a converting analog information into the digital format. That is nothing but sampling more number of samples are done on your voice. So we used to say that your voice is not clear, voice is not clear. It is just because of the device which is converting your analog information into the digital format. If at all that particular receiver is not working properly, not working properly means it is not doing some samples perfectly. If there is no error in the network connection, if the input signal receiver, if the your phone receiver is not sampling more effectively on your voice, then obviously the end user unable to hear your voice more clearly. There would be some disturbance. Okay, so DSP processor is playing a major role in your cell phones also. Means in your cell phone you are having the what is that microphone, you are having the output audio. With the help of the output audio, you are able to hear the voice, and with the help of the microphone, you are able to convert your analog information into the digital format. Means inside your cell phone also, you are having the different types of DSP processors. It is not having only one DSP processor; it is having the so many DSP processors because we are expecting more effective operations by you with the help of the phones. So obviously, based on the user interest, they'll change the pattern. That's the manufacturer will change the pattern. Okay. So means the digital information, the analog information is converted into the digital format. means we are using the DSP processor so many areas. So when you are converting, you are means you are talking very fastly. Let us suppose I'm giving the lecture and my microphone which is there in my laptop, which is installed in my laptop, it should sample more effectively. It should sample my voice more effectively and also my photograph more effectively. Then only the information will be shown properly on the screen. I think here are somewhere in the previous videos, I would have given the some video clips initial during the initial starting point of our class. Then you would have observed some delay between the voice and the video because I increased the pixel size compared to my what is that webcam. So that's why there is a disturbance. Means there is not there is a mismatch between the video recording and the audio. Okay, now. So many samples should be done. So many samples should be done means the DSP processor. If you are increasing the so many samples, that much with that much speed, the DSP processor should work. Okay, so that's why I can say that the DSP processor is working with the highest speed compared to your normal microprocessors. Compared to your normal microprocessor. Okay, so you can see that different types of devices in different types of devices we are using the DSP processor. Okay, so this is about your DSP processor. Okay, so introduction to the DSP. Where exactly we are using the DSP processor? Where exactly we are using the DSP processor? Okay, so the next case is before studying the DSP processor means mm, what we do. Uh, yeah, before studying the DSP processor architecture, I would like to define something related to the DSP processor because we have seen the microcomputer. I told you that before coming to the next class, you go to the microcomputer. Okay, so the microcomputer is nothing but which is looks like this. Microcomputer on the screen you can observe. This is a microcomputer. So I can say that it is a computer. So inside the computer, what we have? We have the microprocessor. We have the microprocessor. I'll take the red. No, green is good. Okay. So this is a micro CPU, central processing unit, means which is a having the mother. What is that microprocessor? And after that, we are having the RAM, ROM, I/O ports, means input port and the output port to interface the input output devices, and we have the timers. Timers means in order to generate the time delay, in order to generate the time delay, or in order to generate the what is that mm, we can say that the digital clock you can use make use of the timer, and we are using the timers to generate the delays also. Why we are using the timers to generate the delay means let us suppose I would like to interface one peripheral device. Peripheral is nothing but the device which is externally interfaced to the microprocessor is called as a peripheral device, or that may be the input or output device. When I would like to interface the input device with the microprocessor, if it's not working with the same speed of the microprocessor, then I should introduce some what is that delay cycles to the microprocessor. So that may be done with the help of the timer. That may be done with the help of the timer. And the same timer can be used to generate the time delay in terms of the seconds for the external devices. Okay. And also the same timer may be used as a counter. So that is a different scenario. I'll explain this one later. So serial communication port and the IO port. Sima, IO port is nothing but it is a parallel communication. I'll come to that particular parallel and serial communication as we move on. Don't worry about it. Parallel means we are using the, let us suppose I would like to send the 8-bit information. So let me give you the explanation also. Why should we have a doubt on that particular serial and parallel, right? So parallel communication is nothing but I would like to send the information in the 8-bit format. Then I'm going to make use of 8 lines to send the information. So I'm not showing all the lines. So totally I'm having the 8 lines. Totally I'm having the 8 lines. So means I would like to send the information in the 8-bit format. 8-bit format. Then I'm using the 8-bit data bus. I'm using the 8-bit data bus to send the information. So this type of communication is called as a parallel communication. Means all the 8 bits are transferred at a time. But if you come to the what is that serial communication, serial communication. Here also I would like to send the information in the 8-bit format, but the information will not be sent using the 8 lines. The information will send using only the 2 lines. Okay, means 8-bit parallel data. Here the 8 bits are transferred at a time, but here the 8 bits are not transferred at a time, but the 8 bits are transferred from here to here. It is in the bit by bit manner. Well, first one bit, second bit, third bit, like that. The information will be transferred. Okay, so this communication is called as a serial communication. Parallel communication means all the bits are transferred at a time. Serial communication means bit by bit manner the information will be transferred. We'll see the more clear information, more clear explanation about the serial and parallel communication as we move on. I think in the second unit we'll come across that one, but don't worry about this particular topic here. Okay, so see, these are the external. These devices are called as a peripherals now. These devices are called as a peripherals. Why we are calling them as a peripherals? Because these devices are externally interfaced to the microprocessor. These devices are externally interfaced to the microprocessor. Externally interfaced to the microprocessor. Because this is a microprocessor. And these external, as they are externally connected to the microprocessor, they are called as a peripherals. And also, more specifically, they are called as a off-chip peripheral. They are called as a off-chip peripheral. Okay, now off-chip peripherals. Okay, we have one more terminology called as a on-chip peripherals. On-chip peripherals. Okay, so just take the points what we are having over here. On-chip peripherals. Okay, now off-chip. What exactly the off-chip peripherals and what exactly the on-chip peripherals? So in this case, I call them ROM, RAM. All these devices are say off-chip peripherals. Off-chip peripherals because they are not a part of the microprocessor IC. This is a microprocessor IC, right? This is a microprocessor IC, and these memory devices and the IO port devices and the communication port devices are not there as a part of the microprocessor IC. So that's why they are called as a off-chip peripherals. They are called as a off-chip peripherals. But if at all the memory devices and whatever the features which you are seeing on the screen in terms of the microcomputer, if all these things are there as a part of the microprocessor itself, as a part of the microprocessor itself, okay, then they are called as a, at that time they are called as a on-chip peripherals. They are called as a on-chip peripherals because the peripherals, they are the peripherals actually. These peripherals are available on the same IC. That's why they are called as a on-chip peripherals. Okay, and mean if you want to see that one, come to this diagram. If you see this one, I'm having this is the entire thing is one IC now. This entire thing is one IC structure. So this is a one IC. Okay, in this IC, I'm having the microprocessor, I'm having the RAM, I'm having the ROM, I'm having the IO ports, I'm having the timers, I'm having the serial communication port line. So means all these means these are the peripherals actually, RAM, ROM, memory devices and the input ports, all these are the peripherals, but they are available as a part of the microprocessor IC. They are integrated as a part of the microprocessor IC. So that's why these peripherals are called as a on-chip peripherals. These peripherals are called as a on-chip peripherals. But if you see this microcomputer, these peripherals are called as a off-chip peripherals. These peripherals are called as a off-chip peripherals. Now, I think you would have got the clear information. On-chip peripherals are nothing but the peripherals which are there on the microprocessor IC itself, or the peripherals which are integrated as a part of the microprocessor IC itself, they are called as a on-chip peripherals. If at all the peripherals are not there on the on-chip, they are externally interfaced to the microprocessor, they are called as a off-chip peripherals. Now, if you go through the explanation in the DSP, you will come across one more terminology called as a on-chip memory. Okay, now so on-chip. Let me take the hyphen. On-chip memory. Okay, now on-chip memory is nothing but these memories are called as the on-chip memories, and these devices are called as the on-chip peripherals. Okay, now means the naming conventions are on-chip memory or on-chip peripherals. They are equal, but they more specifically they will say that on-chip memory. On-chip memory means the memory which is there on the microprocessor IC itself. So that is called as a on-chip memory. And so here the microprocessor, I can define one explanation. I can define one thing called as a microprocessor along with the some peripherals microprocessor along with some peripherals integrated as a part of the one IC, then it is called as a microcontroller. Microcontroller is nothing but microprocessor only, but some of the peripherals are integrated as a part of the microprocessor IC itself on the same IC, then it is called as a microcontroller. So microprocessor based system is nothing but microprocessor along with the off-chip peripherals is called as a microprocessor based system. And microcontroller is nothing but the microprocessor only along with RAM, ROM, IO devices and the timer serial communication port all are integrated as a part of the same IC, then it is called as a microcontroller. But so the naming conventions are nothing but microcontroller means if at all a particular microprocessor is having the memory devices as well as some other peripherals as a part of the IC itself, they are called as a microcontroller. But later on, what they have done is the microprocessor inside the microprocessor only the manufacturer because they would like to would use more effectively means as the microcontrollers are introduced into the market, then in embedded systems in your remotes and all those things they have done make use of they have gone with microcontrollers to design the systems. But when microcontrollers are introduced, the market for the microprocessors are reduced. To increase the market for the microprocessor also, what the microprocessor manufacturers done is they are introduced integrated peripherals. Means they introduced some of the on-chip peripherals. Even though they have some on-chip peripherals inside the microprocessor, they are not called as a microcontroller. They are called as a microprocessors only. Initially, microprocessor is nothing but it is not having any on-chip peripherals. Microprocessor is a simple arithmetic and logic unit which performs the operations and shows the result based on the given information. That's it. It is not having any memory device to store the information. That is what the general purpose microprocessor. But in order to what is that compete with a microcontroller, the microprocessor manufacturers also introduced some peripherals as a part of the microprocessor itself. Okay, now. So that's why in the DSP processor, DSP is not but a digital signal processor. It is a microprocessor only. It is a kind of microprocessor only, but it is having some on-chip memory devices. Okay, so now you got the clear information. On-chip memories or on-chip peripherals are nothing but the peripherals or the memory devices which are there as a part of the microprocessor itself. They are called as the on-chip peripherals and the on-chip memory devices. The peripherals which are external to the microprocessor, they are called as off-chip memories or the off-chip peripherals. Okay, so this is what you should know before going to the DSP processor. Okay, so I'll continue the explanation about the DSP in the next video. Means continuation to this particular video. I think you realize the concept. What is the difference between the microprocessor and the microcontroller, and what is the difference between the off-chip and the on-chip peripherals? Okay, so this is all about your DSP processor introduction. In the next video, we will go to the what is that our mm, academic syllabus. As per the academic syllabus, this it is only for realizing where exactly we are using and how the DSP processor is working and where we are using the DSP processor. Only it is only for realizing that particular concept. Okay, now don't get confused with this one. And this video is not related to your academic session actually, but it is only the introduction part to your DSP processor to realize where how exactly the DSP is working. And we'll go to the more specific explanation about your DSP processor in the next video. Okay, if you are having any queries regarding this particular topic, let me know in the WhatsApp group or in the